So on this standard of area of simple and composite figures, we're looking at level 3 now. So let's read the question. A trapezoid has bases of length 2 meters and 8 meters. So remember, for a trapezoid, the bases are the two parallel sides. The height of the trapezoid is 4 meters, and the slants, which are the non-parallel sides, are 5 meters and 6 meters. So draw a picture of the trapezoid first, okay? So let's see, what could it potentially look like? We'll say that this is the small base, this is the big base. So it looks something like that. Okay, that's not the greatest picture I've ever seen, but it doesn't have to be. It's not an art competition. So something like that. And I'll just erase this little piece here in the middle just to keep it looking a little bit tidier. Alright, so there's an example. Okay. So we know that this is 2, we know that this is 8, we know that the height is 4, we know that this is 5, and this is 6. Alright? Now, if we double all of these digits, what factor will the area increase by? Okay, well, let's find the area of this actual trapezoid itself. So we'll talk about the original trapezoid first. Okay, so its area is base 1 plus 8 base 2, which is 8, plus 10, multiplied by the height, which is 4, all over 2. So 8 plus 2 is 10, times 4 is 40, divided by 2 is 20. So it's going to be 20 meters squared. Now, it says we're going to double all these lengths, and what factor will that increase the area by? So now let's look at the new trapezoid. So we're going to look at the new trapezoid. So we're going to find the area where we double everything. So instead of 8 plus 2, we're going to have 16 plus 4, because the base that was 8 is going to double to 16, and the base that was 2 is going to double to 4. The height is going to double to 8. Now don't make the mistake here. Okay, these are all the lengths doubled. This 2 here is not one of the lengths in the trapezoid. Okay? Some people are going to double that and turn that into a 4, but that's not true. That's not what you should do. This 2 is not one of the lengths in the trapezoid. We're just dividing this in 2, because remember, it would be a parallelogram if we stuck the two trapezoids together. So what do we get then? 16 plus 4 is 20. 20 times 8 is 160, divided by 2 is 80 meters squared. So the area is gone from being 20 meters squared to being 80 meters squared. So what factor did it increase by? What do I have to multiply the first one by to get the second one? Okay, so it multiplies by 4, so increased by factor of 4. Okay? Basic questions you can get. Right, let's have a look. Next one. A rectangle has length 22 and width 18. So let's just sketch it out anyway. I'll draw it out, see what it might look like. It doesn't have to be accurate, it's just to give you an idea of what's happening. That's 18, that's 22. Alright, so if we halve the length by a factor of 2, okay, that's a mistake, so it should be just if we halve the length. Alright, and increase the width by a factor of 2, what will the area increase by? Let's have a look. So if we halve the length, so the length is 22, so our new triangle, a little bit smaller, the length is going to be 11. And if we increase the width by a factor of 2, the width is going to become 36, right? Yeah? So now let's look at the area of the original one. The area of this one will be 18 times 22, which is 396 meters squared. Let's look at our new one. It will be 36 times 11, which is 396 meters squared. So what factor does it increase by? Nothing. The area stays the same. Because if you think about it, we're going to multiply two numbers. We divide one of them by 2, so we make it half the size, but then we make the other one twice the size, so they compensate for each other, and it stays the same. Alright, so what you do is, you basically draw out your figures, you find the area of the first one, then you change it by doubling or halving or multiplying by 3, and you get the new area, and then you see what you have to multiply one by to get the other. Okay. David wants to tile the main wall in his bathroom. The wall is rectangular and has height 3 meters and length 6 meters. If each tile has area 36 centimeters squared, how many tiles are needed to cover the full wall? Okay, so what we're going to have to do here is we're going to have to find the area of the wall in centimeters squared and then divide it by 36 centimeters squared to see how many tiles fit in. Okay? So what you're going to have here is, we're going to have 300 centimeters by 600 centimeters, okay? Because 3 meters and 6 meters, okay? So that works out to be 180,000. 180 centimeters squared is the area of the wall. Alright? Now, you want to see how many of these tiles do I need to make up the whole wall, to cover the whole wall. And that's a division problem. So what you do is 180,000 divided by 36. You can do that with your calculator, you can do it on paper, and you're going to find out that the answer is going to be about 5,000. Okay? So you're going to need 5,000 tiles to cover that wall. So Erica has an isosceles trapezoidal tabletop with bases of length 2 and 1 and height 2. She also has right-angled triangle shaped stickers, that should say. Okay, so I'm going to just put a little note here. Excuse that for a second. Right angle triangle. That doesn't look very tidy. Let me clean that up. Okay. So again, you're going to have to find the area of the tabletop in meters. So the bases are 2 and 1. Okay, so that's 2 meters, which is 200 centimeters. Remember, you add the two bases. You multiply by the 200 and you divide by 2. Okay? So that's the area of the trapezoidal tabletop. Okay, so instead of we're changing it all into centimeters because we're going to be working with the area of the stickers, which are also centimeters. You have 200 plus 100 is 300. 300 times 200 is 60,000. Okay, divided by 2 is 30,000. So we have 30,000 centimeters squared is the area of the wall. Okay, now let's look at the area of each sticker. Each sticker, it's a right triangle. It's base times height divided by 2, which is 30 centimeters squared. Okay, and then to get your answer, you're going to do 30,000 divided by 30. which is 1000. So you're going to need 1000 stickers to cover the tabletop. Okay, here we go again. This is a composite figure. We're going to have a look at the area of this. So it's pretty straightforward, this one, I think, right? So what you have is you have a big white triangle which has had a rectangle which has had a smaller rectangle removed from it. So what you do is you find the area equals, sorry about that, area of big rectangle minus area of small. So let's do the big rectangle. What's the area of the big rectangle? It's 9 times 8, which is 72 meters squared. Small is 6 times 3, which is 18 meters squared. So then the white part, 72 minus 18, which equals 54 centimeters squared. Okay, here's another one. Somewhat trickier, you might think, but let's have a look. There's lots of different ways you can do this. For example, you could look at the white part, you could divide that up into rectangles and trapezoids and find all their areas and add them up. But what I'm going to do is, I'm going to find the whole shape, so I'm going to outline it here. Hold on, that's not good. This whole shape here, I'm going to find the area of that big rectangle, and then I'm going to find the area of this little piece here and of this piece here, and I'm going to cut it out. I'm going to subtract it. So let's see how that goes. So it's going to be big rectangle minus small rectangle minus triangle. Okay, so the big rectangle, let's have a look at that first. So the area equals, well, it's going to be, let's have a quick look. So 12 is the full distance across, and I know that because this distance here is 8. Okay, so the whole thing is 12, so that's going to be 12. That's the length, and then the width is 8. So 12 times 8 is equal to 96. That's the area of the big rectangle. Now, let's find the area of the small one. Okay, so 2 by 8. Okay, area equals 2 times 8, which is 16. And by the way, this is centimeters squared. Centimeters squared. And now we're going to do the triangle. And the triangle, well, is going to be 4 times 6. Okay, and the right angle is in there because it's the corner of a rectangle. So, what have we got? Area equals 4 times 6 divided by 2, which works out to be 12 centimeters squared. So now, what you do is you do 96 minus 16 minus 12. Okay, and it works out to be area, 96 minus 16 is 80, minus 12 is 68 centimeters squared. And that's it.